This is the enemy AI we're building today in Godot. Let's jump into Godot. In a previous video, we built a first-person controller for mobile, but you don't need to have watched that one to follow along here. This tutorial works completely on its own. Today, we're building an enemy AI that can detect the player, chase them, and attack when it gets close. First, we need our enemy to be able to move around the level intelligently, and for that, we need a navigation mesh. I'll long-click on the floor node and select Reparent to New Node. I'll search for Navigation Region 3D and hit Create. Now our floor is nested under a Navigation Region 3D node. Next, I'll click on the Navigation Region 3D node, go to the inspector, and select the Navigation Mesh property. Then click on it to create a new navigation mesh. Now I'll click Bake Navigation Mesh at the top of the viewport. Once the baking process finishes, you can see a blue overlay covering the entire floor. That's our walkable navigation area, and this is what the enemy will use to path toward the player. Now let's create the enemy itself. I'll long-click on the main node, select Add Child Node, and add a Character Body 3D. I'll rename it to Enemy. With the Enemy node selected, I'll long-click it, add a Child Node, and add a Mesh Instance 3D. In the inspector, I'll click on the Mesh property and select Capsule Mesh. That's the visible shape of our enemy. Now I'll long-click the enemy node again, add a child node, and add a collision shape 3D. In the inspector, I'll set the shape to a capsule shape 3D. We need this so the physics engine knows the actual physical boundaries of the enemy. Without it, the enemy would have no collision and could pass through walls or the floor. I'll click on the enemy node, go to Transform in the inspector, and change position Y from 0 to 1 so the enemy sits properly on top of the floor instead of halfway inside it. Now, using the blue arrow in the viewport, I'll move the enemy away from the center of the level since that's where our player starts. You can also do this directly from the inspector by adjusting position Z under Transform. Now I'll click on the enemy's Mesh Instance 3D, go to Geometry in the inspector, and click on Material Override. I'll select Standard Material 3D, then change the albedo color to red. This isn't strictly necessary, but it makes the enemy easier to spot against the floor, and honestly, it just feels more like an enemy this way. I'll long-click the enemy node, add a child node, and add a Navigation Agent 3D. This is what will actually calculate the path for our enemy across the navigation mesh we baked earlier. Now I'll long-click the enemy node again, add a child node, and add an Area 3D. I'll rename it to Detection Area. With Detection Area selected, I'll long-click it, add a child node, and add a Collision Shape 3D. In the inspector, I'll set the shape to Sphere Shape 3D, then click on the shape and change the radius from 0.5 to 10. This radius is basically the enemy's eyesight. It determines how far away the enemy can detect the player. The bigger this number, the earlier the enemy will notice the player from a distance. If you want a more alert enemy, increase the radius. If you want the player to be able to sneak closer before being spotted, keep it smaller. Now let's do the same thing for attacking. I'll long-click the enemy node, add a child node, and add another Area 3D, renaming it to Attack Area. I'll long-click Attack Area, add a child node, and add a Collision Shape 3D, setting its shape to Sphere Shape 3D again. But this time I'll change the radius from 0.5 to 1.5. This radius is much smaller than the detection radius on purpose because this represents the enemy's actual attack range. It should only be able to attack when it's really close to the player, not from far away. This next part is important. I'll click on the player node, and in the inspector at the top of the panel, there are two arrows on the right side. I'll click the right arrow twice to get to the Groups tab. I'll click the plus icon, type Player as the name, and click Create. Now you can see Player has been added to the scene groups with a check mark next to it. We're doing this because our enemy script is going to check whether a body that enters its detection or attack area belongs to the player group. That's how it knows it found the actual player and not some other object. Now I'll click on the enemy node And from the top of the scene panel, select Attach Script, then click Create. I'll save the scene so everything we've set up so far is preserved. Now let's start writing the actual enemy AI script. I'm going to add this piece by piece, and after each part goes in, I'll explain exactly what it does. Let's start with the very first line. This tells Godot that our script is attached to a character body 3D node, which gives us built-in physics movement functions like move and slide. Now let's add our state enum. This creates a custom type called state with 4 possible values: idle, patrol, chase, and attack. This is how we're going to keep track of what the enemy is currently doing. Next, let's add a few exported variables. These are exported variables, which means they'll show up in the inspector so we can tweak them without touching code. Move speed controls how fast the enemy walks while patrolling. Chase speed controls how fast it moves while chasing the player. Attack range is the distance at which it can attack. Gravity controls how fast it falls, and patrol points is a list of positions the enemy can walk between when it's not chasing anyone. Now let's grab references to the child nodes we set up earlier. These lines grab references to the child nodes we already created: the navigation agent, the detection area, and the attack area, so we can use them directly in our code with these variable names. Next, let's add a few internal variables to track the enemy's state. Current state starts as idle. Player starts as null, since no player has been detected yet. Current patrol index keeps track of which patrol point we're heading to. And in attack range is a simple flag that tells us whether the player is currently inside the attack radius. You might start seeing some errors appear in Godot at this point, and that's completely normal. The script isn't finished yet, so some of these functions and variables aren't fully connected. As we keep adding the rest of the code, these errors will resolve themselves. Now let's add the ready function. The ready function runs once when the enemy first spawns into the scene. Here, we're connecting our detection area and attack area signals to functions that will run whenever a body enters or exits them. Then, if we've set up any patrol points, we switch the enemy into patrol state and send it toward the first patrol point. Next, let's add the physics process function. Physics process runs every physics frame. First, we check if the enemy is on the floor. If it's not, we apply gravity by pulling its vertical velocity downward. Now, let's add the state machine logic inside this same function. This match statement checks whatever the current state is and runs the matching behavior. If it's idle, we just stop horizontal movement. If it's patrol, chase, or attack, we call the matching function, which we'll write next. Finally, move and slide actually applies the calculated velocity to move the enemy in the scene. Now let's write the patrol function these calls depend on. This function handles patrol behavior. If there are no patrol points, it just exits. If the enemy has reached its current destination, it moves on to the next patrol point in the list, looping back to the start once it reaches the end. Otherwise, it keeps moving along the path at our regular move speed. Next, let's add the chase function. This handles the chase behavior. If we've lost track of the player, we go back to patrolling or idling. If the player is now within attack range, we switch straight to the attack state. Otherwise, we keep updating our navigation target to the player's current position and move toward them at our faster chase speed. Now let's add the attack function. While attacking, we stop the enemy's horizontal movement completely. If the player disappears, we go back to idle. If the player steps back out of attack range, we switch back to chase. Otherwise, we just keep the enemy facing the player. Now let's add the shared movement function that patrol and chase both rely on. If there's no more path to follow, we stop. Otherwise, we get the next position along the calculated path, figure out the direction toward it, flatten out the vertical components so we don't try to move up or down, normalize it so it's a clean direction vector, and then apply that direction to our velocity at whatever speed was passed in. Finally, we rotate the enemy to face the direction it's moving. Next, let's add the rotation helper function. This smoothly rotates the enemy to face a given direction. We calculate the target angle using atan2, then smoothly interpolate the enemy's current rotation toward that angle instead of snapping instantly, which makes the turning look natural. Now let's add the function that keeps the enemy facing the player during an attack. This function calculates the direction from the enemy to the player, flattens it, and passes it into our face direction function. Now let's add the signal callbacks for the detection area, starting with body entered. This runs whenever something enters the detection area. We check if that body belongs to the player group. If it does, we store a reference to it and immediately switch to the chase state. Next, let's add the body exited callback for the same area. This runs when something leaves the detection area. If it's the player leaving, we clear our reference and go back to patrolling or idling, since we've lost sight of them. Now let's add the same two callbacks for the attack area, starting with body entered. This runs whenever something enters the attack area. If it's the player, we flip our in attack range flag to true. And finally, let's add the body exited callback to close out the script. And this does the opposite. When the player leaves the attack area, we flip that flag back to false. That's the complete enemy AI script. Now that the script is finished, let's test it out. I'll hit play. As you can see, the enemy is just standing still right now. If we stay far away, it doesn't react to us at all. But the moment we step into the detection area, the enemy spots us and starts moving in our direction. There's a small issue I want to fix before we continue. Back in the project, I'll go into the player scene and click on the head node, which sits above the camera and represents the center of our character. In the inspector, under transform, I'll change position Y from 0 to 0.5, so the camera sits properly at head height instead of at the character's center. I'll save the scene. Now back on the enemy node, I'll long-click the enemy's Mesh Instance 3D, add a child node, and add another Mesh Instance 3D. In the inspector, I'll set its mesh to torus mesh. I want to use this as the enemy's eye. Under transform, I'll change scale from 1 to 0.5 to make it smaller, then use the green arrow for position Y and the blue arrow for position Z to place it on top of the capsule's head. You can also do this directly from the inspector by setting position Y to 0.4 and position Z to 0.1. Now, as you can see, our enemy actually has a face. Let's hit play one more time. As you can see, everything is working. Wherever we move, the enemy's face turns to look at us and it follows us and closes the distance. If you want to learn how to build the first-person controller we used in this video, check out this tutorial. I'll see you in the next one.